Okay, so this is for quiz 6. In the first question, you see several data points here. So you can easily find the z-scores. All you need to know is the mean, which is the average of these numbers. You can calculate that. And the standard deviation. You can also find that. So once you know the mean and the standard deviation, you can find the z-scores corresponding to each of these points. And then you would plot the QQ plots, which is also known as the quantile plot, the normal quantile plot. You would put these numbers in increasing order on the x-axis, and then you would put the z-scores again in increasing order on the y-axis, and then you would mark the plots corresponding to each, matching these points with their z-scores. And once you mark those points, if there's a pattern that looks like a straight line, then you say yes, this is normally distributed. If there's no such pattern, then the answer is no. In the second one, this is pretty similar, only we have a larger data sets. Again, you can use Excel. You would list off all of these numbers, and then you can easily calculate the mean and the standard deviation. And there's formulas in Excel that do that. So once you know the mean and the standard deviation, you can also calculate the z-scores corresponding to each of these. And then you can use Excel to create the QQ plots. And you can see if you will see that in this case the points lie reasonably close to a straight line, so it is a normally distributed data. In the third question here, you are given a mean value and a standard deviation, and then this is kind of tricky. It's a very simple question, but it's kind of tricky. So just read that. What are the values of the mean and the standard deviation after converting all pulse rates of women to z-scores? So when you convert all given data set to z-scores, the mean and standard deviation of a set of z-scores is always the same. The mean is 0 and the standard deviation is 1. So regardless of what these given numbers are, after converting everything to z-scores, your mean will be 0 and your standard deviation will be 1. And this is about the units of the z-score. Z-score basically doesn't have a unit, because it's a number that tells you how many standard deviations a certain score is away from the mean. So you would mark D. So here you are given the mean and the standard deviation, and if you look at the graph, what is this area? So the area is bound by this point 85. So we need to find the z-score corresponding to 85. And you can use the formula, which is 85 minus mean 100, which makes negative 15, divided by the standard deviation, which is 15, and that would give you a negative 1. So the z-score is exactly negative 1.0. So you would go to this table. See, this is the far left column is the z-score. And this gives you any of the decimal points. Like if your z-score is negative 3.02, negative 3 point is here and 02 is here, and they meet right there. So our z-score is exactly negative 1.00. So this is the first column here after this line is where we look at once we find negative 1 here, which is 0.1518. So 0.1518 is the area of this shaded region. Okay, so now we can go to the next question. Okay, so this is also a similar question. It's a bit tricky though. So in part A, it's asking you the probability that at least 765 people vote. So your mean here is, the 62% is the given probability. So I actually did some calculations here. So this is our population, and this is the 62% of it. You can look at the formula bar. So this is our mean. And then the standard deviation can be calculated as follows: n times p times 1 minus p, the square root, which makes this. This is your n. Your p is 62%, so 0.62, and your 1 minus p is 0.38. So this is the standard deviation. And then here, this is your z-score for 765. So that's, so since we're looking for px greater than or equal to 765, that means we're looking at x less than 765. So it might make sense to, I don't know, either you can try the 764 or 65, but either way, you'll find that 765 minus the mean divided by the standard deviation. This is your z-score, and then you would go back and look at, it was 2.07 something, so 2 is here, and 07 is like it's over here somewhere. So it's about 0.9808. So 0.9808. So that would be, so that's actually the probability that we have less than 765 people voting. So at least 765 people voting would be 1 minus that. So it was like 0.98 something. And then the actual, the probability we're looking for would be like 0.02. And then in these answer choices, it's asking you, so what does this mean? Basically, our probability is 0.02, which is definitely less than 5%. It's not at least 1%. So if it's at least, or if it's around 1%, if it's at least 1%, we would say that people are being honest because it's a very close probability. But if it's less than 5%, which it is in our case, then you say people are being less, some people are being less than honest. So here the mean is given, standard deviation is given, so the probability that a randomly selected adult has an IQ less than 133. So you would find the z-score for 133, which would be 133 minus 105, that's 28, divided by 20, which is 1.4. So the z-score is exactly 1.4. So once we find the corresponding value in the in this table, that would be the answer. So 1.4, going to the positive side, 1.4 is here, and we don't have any decimals, so it's 0.00 actually. So that will be 0.9192 is the probability we're looking for. So here, finding the critical value, remember this is alpha, which is 0.06. That's the area to the right of the z-score. So we need to find 1 minus alpha. So 1 minus 0.06 is 0.94. So find so that's the probability. Where do you find 0.94 in this table? So going all the way down here, see this is 0.93. Okay, so 0.9406 is here, 0.9394 here. So 0.94 is exactly right here in between, which is 1.5, and it's in between, so it's 1.55, between 1.55 and 56. So like you can say 1.55 or 56. So we need to find the indicated z-score here. So here's the z-score. The area, the probability is given, which is 0.8438. So we're going to find this number on the table and see which z-score it corresponds to. So it was again 0.8438. So 0.8430 it's exactly here, 8438, and it corresponds to 1.01. 1.01. And here we need to find the area of the shaded region. So this is the area. It's very simple. You see the z-score here, 0.81. So we're going to find the z-score on the table and see the corresponding probability value. So 0.81. So going to the positive side, here it is. Go down to 0.8 and 81. So it's 0.01 here. So 0.81 is right here, which is 0.7910. So which graph represents the 84th percentile? So this is 84th percentile is obviously going to be marked to the right of the y-axis, the mean. So it can't be A or D. And once it's marked here, 84th percentile, we're looking at the shaded region to its left. So that will be B in this case. And how do you find the temperature for the 84th percentile? So the percentile is basically the probability, which is 0.84. So you go back to the charts and find 0.84. So going here, this is 0.80s, 83s, 83, pretty close. 0.8413 is here, which is z-score 1, and 8389 is here, which is z-score 0.9. So it's right in between. Actually, this is 0.99. So 0.99. So 0.99. So it's right below 1. So it's 0.99 is the temperature for P84. So here, which diagram shows the temperature readings between negative 2.16 and negative 1.61. So both of these points must be marked on the graph. Since they're negative, they're going to be towards the left of the bell curve. So the center is here, the mean, so it's going to be to the left. Both of them are marked. And since we're looking at the readings between, the shaded area should be in between those points. So it shouldn't include the left tail. It should be in between. So B is the correct one. And the probability, to find the probability, you would have to look at the corresponding value for z-score negative 1.61. So the number corresponding to this z-score and then the number corresponding to the other z-score, and their difference would give you this shaded area.